Hello, my name is Berto Pandolfo. Welcome to my presentation titled Community Opportunity Object Production in the City. The presentation is divided into four parts. Part 1, Plastic Objects. Part 2, Object Making. Part 3, The Community, the Material, the Machine, the Object. And Part 4, Object Complexity and Object Meaning. Man-made plastic first emerged in the middle of the 19th century. It was initially developed as a substitute material for more precious materials such as ivory and amber. The advantages of plastics were soon recognised. Plastic is now ubiquitous, found in every sphere of life, and although it is the answer to many of society's needs, it also represents one of our greatest challenges. In 2018, global production of plastic was 359 million tonnes. Plastic is strong, light and durable. It is easy to process and now, because of organised systems of production, very affordable. Much effort has gone into the development of better plastics and faster processing methods. However, solutions addressing the end of life of plastic has received comparatively less attention. The three ways and options to deal with end-of-life plastic is to bury it, to burn it, or to recycle it. The easiest and least complicated method of managing waste plastic is to bury it. In the US, more than 75% of waste plastic ended up in landfill. In the EU, it was nearly one-third. The problem with putting plastic into landfill is that it can take hundreds of years to decompose and potentially leak pollutants into the soil and water. Approximately 1/4 of waste plastic is burnt. Converting waste plastic into energy through incineration is appealing as plastic has a high energy value. Modern incinerators can minimise the amount of released pollutants, but they can also release pollutants such as dioxins and heavy metals. Recycling waste plastic into new products conserve resources, reduce energy use, and reduce greenhouse gas emissions. Currently, less than 20% of global plastic is being recycled. One of the most significant barriers to plastic recycling is contamination. Due to the volume of waste plastic and the variety of plastic types, contamination is a significant barrier to recycling plastic waste. Recycling plastic has been possible for decades, and companies have made significant advances. Multinational beverage companies are using recycled content in their containers. These examples are interesting due to the nature of their products, which are predominantly transparent clear plastic. To include recycled content into transparent bottles requires complex and sophisticated material management systems. Addressing waste management and large-scale manufacturing utilising recycled plastics require large tracts of land, which means they generally find themselves on the urban fringe where costs are reduced. How then could a plastic recycling initiative be imagined in central urban areas? And given that the industrial scale of multinational packaging companies is not feasible in an urban context, what scale could be possible to carry out this type of activity? And if the recycling material is being consumed in the urban context, could it be recycled and reused in that same context? The concept of object making in the urban context presents significant challenges but also interesting possibilities. Object making was dominated by making by hand until the Industrial Revolution of the 18th and 19th centuries. Societies that were largely rural became industrialised and urbanised. This new way evolved into a model of making objects on a mass scale. During the 20th century, many countries adopted manufacturing industries into their economies. Manufacturing became an important contributor to skills, learning and commercial activity. There are indications that object making is making a comeback. The comeback is happening in two ways. The first is a return to countries of origin, also known as backshoring. and the second is a move from making in the city fringe back into urban centres. Prior to the mid-20th century, manufacturing was diversified across the world. Many nations were self-sufficient in terms of the many objects they required, and manufacturers were located close to urban centres. The early stages of globalisation saw manufacturers move their activities away from high-density areas. Towards the end of the 20th century, manufacturing was further rationalised into locations where costs, particularly those associated with labour, were lower. This was sometimes referred to as offshoring. Offshoring is a strategy widely adopted by Western manufacturing companies that move their activities into foreign countries in order to maintain their competitive advantage. There are signs that this trend is turning and companies are re-evaluating the importance of location. Backshoring is occurring because labour and transport costs have increased and the quality and flexibility has fallen in locations that were once more competitive. The advent of advanced manufacturing technologies, or AMT, is another reason motivating manufacturers to backshore their activities. AMT reduces the benefits of low-wage economies by reducing the share of labour content. AMT is initiating a backshoring of manufacturing companies back to home countries. AMT does not foster globalisation and fragmentation of production. Instead, it focuses on production and a trend towards stronger regional and local value chains. The contribution of AMT to backshoring is also playing a role in bringing manufacturing back to the urban setting. While urban manufacturing suffered during the 20th century, trends of the 21st century is indicating a possible return. Next generation manufacturing is likely to be small and discrete. The focus will be on fast changing products made to higher specifications, customized to individual requirements and made in short runs. The disruptive nature of AMT is perfectly positioned to support the radicalisation of how objects are made and consumed. AMT is not the dirty and noisy activity epitomised by large factories of the last century. AMT will allow for quieter modes of production that will be more suitable to high-density environments. It is more sustainable to produce within the city, particularly from an economical, ecological and social point of view. And being located in the urban context offers a direct proximity to customers and highly qualified staff. Examples of a return to making in an urban context is evident across the object spectrum. Some examples include soft goods, microbrewery, jewellery, and clothing. These urban-based makers distinguish themselves through their modest scale, ability to customise, and strong community connection. These maker communities, like any community, provides a platform for members to feel connected to something. Being a part of a community, whether it is a maker community or not, is essential to our well-being. Building and participating in a community contributes to ordering and making sense of an otherwise fragmented world. One notable community of makers was born out of an understanding that making has significant therapeutic value. Inspired by the once common backyard shed, the Men's Shed is a community-based organisation whose primary activity is the provision of a safe and friendly environment where people can work on meaningful projects at their own pace, in their own time, in the company of others. Communities understand the importance of operating at a human scale. A design research approach was adopted that was practitioner-led. An analysis of the material flow within a particular community identified a material appropriate to study. Tests were conducted to transform the material from waste product to a resource. Capabilities within the community were harnessed to transform ideas into practical, object-based solutions. The choice of working with the community is proposed as a means to address the void that exists between waste material management conducted on a mass scale and the single householder wanting to effectively recycle materials. The scale of a community enables a model of production that is feasible and informed by the needs of that community. A city-based university was seen as a suitable candidate community for this study. Its proximity to the urban centre, its scale, and the richness inherent in a university context provided a suitable platform. The city-based university selected for this project is also where the author is employed. The city-based university is a medium to large public university. Like many other similar-sized organisations, it is a microcosm. Its core activities are education and research, and in support of these central functions exist other services and activities such as retail businesses, gyms and sporting facilities, and a wide range of social and cultural groups. During teaching periods, thousands of people move throughout the campus. The locations where people are most visible are at food and beverage outlets and on principal walkways between campus buildings. Observing people at food and beverage locations revealed a high occurrence of takeaway packaging. Single-use packaging was observed being carried by people on campus, but also in bins, on tables, and discarded as litter. The use of single-use packaging is a problem, but it also represents an opportunity. Firstly, packaging material is a potential resource. Secondly, if the resource could be collected and reused on campus, it could save in new purchases, waste management, and transport. Determining which of the single-use packaging would be suitable for further investigation was driven by pragmatic concerns around purity and cleanliness, that is, contamination. The coffee cup lid presented the most promising material. It is easily distinguished and the colour variations are limited to black and white. And importantly, coffee cup lids are marked with a material recycling identification number, making identification easy. The next stage required setting up a strategy to collect the material. Specially marked boxes were positioned at strategic locations in the photocopy room, lunchroom, and adjacent to other waste bins. Boxes were marked with clear instructions. Community members fully supported the initiative and contributed by aiding in collecting and encouraging others to participate. What to make using the coffee cup lid material involved an exploration into the complexity, size, and function of possible object ideas. Contemporaneously, an exploration into the various making processes available at the university was conducted. A variety of technologies were found, but the most suitable was the robot arm printer. This technology locates a plastic extruder on the end of a robotic arm. The robot arm extrudes plastic in accordance with a 3D digital model, a similar concept to how most desktop 3D printers work. Co-evolution of design, exploration, and robot test prints enabled one to inform the other. As it became clear that some designs were not possible to print, they were eliminated. And objects that were previously considered unsuitable re-entered consideration. It was necessary in this stage to consider the physical limitations of polystyrene. Polystyrene is relatively brittle, but it is used widely in single-use cutlery, cups and glasses, disposable shavers, and many toys. It is a versatile material. It can be injection molded, extruded, expanded, and vacuum formed. The coffee cup lid is vacuum formed. The short list of objects was identified, including folder stands, various containers, book stands, and leaflet holders. The book stand was found to be the most suitable object as it satisfied a number of the key criteria determined by limitations of the robot arm printer. The book stand is an object used commonly in libraries and bookstores to display books. It supports a book in a horizontal and open format. It is made in a variety of materials including plastic, timber and sheet metal. A design was finalised and a test print was conducted using virgin plastic to verify the 3D CAD model. The coffee cup lids needed to be reformatted so the robot arm could print it. The first step was to put the material through a shredder to reduce their size into a form suitable for printing. The first test print with the shredded polystyrene failed because the shavings were too light. The material did not have enough mass to fill the extruder chamber. It was necessary to transform the polystyrene shavings into pellets. I produced pellets by extruding the polystyrene shavings into a spaghetti-like form. I then shredded the spaghetti polystyrene to produce pellets that was denser and thicker than the shavings. Now armed with polystyrene pellets, an attempt to print the bookstand was conducted. Unlike the print using the virgin material that was successful on the first attempt, numerous tests were required using the pelletized polystyrene. Issues that emerged including delamination between layers, uneven shrinkage, and bowing. Polystyrene is not a common material used in digital printing, which is why there were so many problems. Polystyrene is more commonly used as a blend, such as in ABS. Following more tests, a successful combination of print temperature, layer height, and print speed was found. When lockdown due to COVID-19 was enforced in March 2020, the impact on this project meant the testing stage of the project was not able to be completed. This stage had planned to produce a small run of bookstands to be placed in the library. This would have provided the opportunity to test the bookstand in situ and gain feedback from librarians and library patrons, who were also members of the university community. Notwithstanding this unanticipated disruption, reflecting on the completed project component of the project revealed a number of interesting insights. The closed-loop system of object making utilised in this project in itself is not a novel concept, but some of the specific outcomes observed may contribute to the broader discussion on closed-loop making. The key takeaway items relate to object complexity and object meaning. The bookstand represented in this project is not a complex object. Made from a single material, it is not difficult to make and it was designed to fulfill a straightforward task. This simplicity, however, does not detract from the necessary service it provides. There are many simple objects that contribute to the proper functioning of our lives. All around us, objects perform rudimentary tasks, and as much as we would like to remove them in a bid to reduce the problem of overconsumption, many simple objects perform useful functions. Overconsumption is a problem because objects are made from virgin material. They are made in faraway places, they require transport over long distances, there is no connection with the end user, and there is no end-of-life plan. The provision of simple objects made in a closed-loop system in partnership with communities is one way to directly respond to these issues. This project highlights the value of the entire process of object making, from material collection to material transformation through to end of life. The humble coffee cup lid in the context of this project can now be viewed as a part of a sustainable solution with regards to plastic waste and overconsumption. The coffee cup lid and the book stand it became is now linked to the community that found it, revalued it as a resource, and gave it new life. Enriching the meaning of simple objects may be one strategy to ensure against unnecessary disposal and encourage the long-term use of objects. Thank you for listening to this presentation.